Hello, everybody. Welcome to Bespin Global's webinar on benchmarking and performance testing. I am Aditya Deshmukh, and I lead the engineering and solutions function as Bespin Global. Uh, with me, we have a few great Bespiniers on the call today. Nishal, please introduce yourself.
Hi, I'm Nishal. I'm a cloud architect with Bespin Global. I work on the delivery side of our organization. I help clients run and optimize their workloads onto the cloud, but I also participate in certain pre-sales activities, like right now. I mainly work in the GCP space, but I also help clients when they need any AWS help as well.
And we have our senior sales executive, Mitch Freitas, in the call. Hey, Mitch.
Hey, Aditya. Again, I'm Mitch Freitas, one of our senior sales executives here on the West Coast, helping our clients with their digital transformation efforts and supporting their initiatives across the board. So glad to be here.
Mitch, while we are at it, maybe you can talk a little bit about Bespin Global in general before we deep dive into some of the performance areas.
Yeah, no, great idea, Aditya. We can give some background on Bespin and then jump into the heart of the discussion. So for all intents and purposes, Bespin Global is a top 10 global multi-cloud managed services partner and reseller. We've been recognized by Gartner 5 years in a row on their Magic Quadrant for cloud MSPs. Very proud of that. We're top tier partners with AWS, Google, as well as Microsoft Azure. We actually work with over 3,000 customers and have 1,100 cloud experts in 12 global offices around the world. Bespin provides services and tools that help with all aspects of adopting, building, managing, and optimizing cloud and data environments. And one area where we've had a lot of experience is helping our clients optimize their performance and cost through performance testing and benchmarking of their workloads on the different cloud processors. And that's really the focus of our discussion today. I'll hand it back over to Nishal and Aditya to take you through that.
Thank you, Mitch. So Bespin started in the US last year, and we have done more than 10 projects already helping customers on various performance benchmarking and optimization projects. Nishal has led many of those initiatives. And today, our objective is to share some of our best practices and learnings from them. Hey, Nishal, are customers interested in performance benchmarking? And what are some of the use cases we are seeing recently?
Hi, Aditya. And yes, customers are very interested in performance benchmarking, right? Like, I think the answer here is fairly simple. Like, do customers want to save money? Usually the answer is yes. Benchmarking your application, your technologies, your services, they can save you a lot of money. Like initially, you may be investing maybe 5 to 6 figures just to figure out how your environment works. But in the long run, right, that could be a 7-figure, 8-figure saving of money, right? So customers are very interested in that. And some of the use cases include your applications, like if your application is running on Java or Python or Go, we can benchmark that. Or infrastructure, right? Like Kubernetes, your virtual machines, anything running on that. What processors will be the most useful? Your database technologies, Cassandra, Elasticsearch, SQL databases, MySQL, Postgres. And of course, your big data, right? Your EMRs with Hadoop and Spark.
Definitely. One of the things we have seen is that every workload is different from a customer perspective, right? So what is our methodology around helping customers with their workloads? Can I say that one set of processors is better than others? Can I say that one set of programming languages is better than others? What is our way of looking at things?
I don't think you can ever definitively say one set of processors or a language is better, right? I think depending on the workload, some languages will introduce different libraries or different sets that you can utilize that make it quicker on their end. Same thing with the processors. Like some processors may do some security services really efficiently, some encryption, decryption, whereas others might focus on just pure compute intensive workloads. So I don't think there's a definitive answer, but depending on the use case and the workload that you're currently using, we can find the best processor for a customer to use.
You did mention about the Kubernetes workloads, Nishal. And Mitch, some of the conversations we're having with customers, definitely Kubernetes has been one of the key areas where performance benchmarking is of interest. So Nishal, in terms of Kubernetes performance optimization, how do we go about things? What is our methodology that you have done the projects with our customers?
Yeah, so we've done a numerous amount of projects involving Kubernetes performance optimization. So we do have a specific methodology that we follow. It consists of 8 steps essentially. But before we get to those steps, right, like we always want to make sure the application is Kubernetes ready, right? Like if you have an application running on a VM, it's not going to be the same as it's running on Kubernetes. Like on a VM, you could have a stateful application running fairly well and it wouldn't be an issue but on Kubernetes, to really get the full utilization of its power and optimization and saving on cost, you want to try to make your application stateless. And of course, you have to be able to containerize that application, right? Or else you can't really run on Kubernetes. So that's the biggest thing. And then you also want to use languages that are more geared towards containerization. So Go and Python are some notable examples that will really have good performance when you're running on Kubernetes. So there's certain things you want to consider before you want your application running on Kubernetes. And then after that, you want to make sure your cluster is ready for your application, right? So there's a lot of minute details that you want to configure, like the right VM type and size for your nodes, making sure you're getting the max performance, and as well as making sure you're using all of the different features that Kubernetes allows, especially in GCP where there's a ton of different features. And you want to make sure like all of the external services that your application needs are also configured as well before you want to performance test your Kubernetes environment. And then after that, we would be able to follow like essentially an 8-step process. This is mainly geared towards GKE and GCP. So the first step, right, is you want to know your GCP GKE quotas. So you don't just want to over provision on nodes or pods. Like one notable limit is each node in GCP is restricted to 110 pods. So if you want like 300 pods on a single node, you won't be able to do it, right? So, and there's reasons for that. So make sure when you're writing your application or just make sure you're following it in a way that it's going to work best on the service you're going to use. Ready? So the next step would be to get a baseline of your application in the cluster. So once you have your application in a pod running, or you want to submit a job, right? You want to run a single job of your application on probably just a normal VM type, so like an E2 standard. And you should start by running it on a larger VM, just so there's no performance bottlenecks right off the start. And you can get an accurate measurement of your CPU utilization and your memory usage. And also how long your jobs are running. If it's short-lived, then that'll be really important. If it's a long-running job or a long-running application in a pod, maybe you want to look at performance, right? Like the number of queries that are being processed per second. All that is very important. And the real, when you track your CPU utilization and memory usage right off the bat here, you'll know what you need to put in your YAML files for your requests and limits for your CPU and memory. Now, when you're performance testing initially, you may not want to put those limits right away, just because you can really see the benefits of a node type or a processor. But of course, once you're production ready, right, you definitely want those requests and limits in there, unless it's a very specific use case, just because that'll allow your application to have the amount it needs and it won't shut down in an unnecessary way. So the next phase, right, is to find the group of VM types and sizes you want to test. So I'm sure once you've seen that initial CPU and memory usage, especially for GCP, right, they give you different VM types. So you have your high memory or your high CPU. So if you're CPU intensive, use a high CPU. If you're memory intensive, look at high memory. If it's fairly standard throughout. But standard means you're going to get like 4 gigs of memory to 1 vCPU. So as long as your CPU to memory is somewhere around there, then a standard should be fine. And then look at different processors and different VM types, right? Like we have N2Ds, we have N2s, we have E2s, and we have Google's newest offerings consisting of T2Ds. And they all provide various benefits. Like T2Ds are really good at price performance. E2s are very cheap. N2s have really high performance, especially the newest processors such as Ice Lake, which gives a big boost in performance. So make sure to look at those. And then find your performance, run your tests for your applications on each of these VMs, and that should give you a good idea of which node and processor you'll want to use. So next is going to be really geared towards your application, right? You want to run various load tests. So yeah, just running one test and in a simple way would get you what you need as a baseline, but you want to stress your application, right? You want to see what it's like at maybe lower times, higher times, just so when you're production ready, you'll have all that information ready to go. So let's say you have a ton of short-lived jobs that you want to run, right? So run like one job, run 10 jobs, run 50 jobs, run 100 jobs. See if there's any issues. Do all the jobs finish? Is what your application doing supposed to be happening? Is everything finishing, or are there restarts happening? Are the containers restarting? Are there any issues that you're encountering? Right, so find all of that information. And you can use different tools on Kubernetes to test this. You can use Locus, which is an open source load testing tool, which you can run across many machines. And then SpeedScale is a very useful tool as well, which allows you to replay traffic and stress test your APIs with like real world scenarios. So you can capture that traffic from your real time application that's sitting in production and then replay it in your test scenarios. So this will save you a lot of time on your end by being able to use these tools. And then to capture metrics, right? Like you can have your own, use the different services that cloud provides, right? Like cloud logging and monitoring are very useful. And if you have to move a lot of data, then export it to BigQuery and capture it there. Or you can use your own custom scripts like Python or Shell or Bash in whichever way you want. If you want to load test your application a different way, you can use that, or you capture certain metrics that aren't as easy to get right from some cloud services. You'll be able to do that as well. And make sure to track all the necessary metrics you need, right? So whatever your application is geared towards, if it's runtime or number of operations per second that needs to be finished or minute, CPU utilization, memory utilization, if it's network, if network is a really big bottleneck, or disk IO, then make sure you track that, right? Because disk is also another variation of GCP that you can change. You can use a high performing disk like an SSD or a more standard disk like an HDD, and you can increase the disk size if need be. And after that, you want to try your best to stress test your application, right? Run it to the maximum. Submit as many jobs, for example, as you can, whether that's 1,000 or even more, depending on your workload. Or if it's something that's long running, right? Like submit in a very high number of queries where the node is stressed, and see if everything that you submitted, all your operations were able to complete, or if there was any issues happening. And see if, going back to the node types, right? Like let's look at if one of the node types was able to complete it and one of them was not able to complete it. This might save you in an actual production scenario where you would get an increase in requests immediately, and your application, your infrastructure would already be ready to handle it.
Right.
And after that, right, like analyze all of the results you've gotten. So once you have all of this information, you should be able to find out what VM variant is the best in terms of processor and what VM type, so high CPU or high memory. And also look at the cost, right? Like, what is important to the customer? Is it cost? Is it performance? Is it a mix of price per and performance? And then that's when you can decide, due to GCP's numerous uh, types of VMs and variations, you'll be able to get exactly what you're looking for. And after that, this is where you can run even further tests to optimize on cost, right? Now you have the infrastructure you think you'll need, but there's even further we can go. We can use preemptible nodes. We can use custom VM types that GCP has. So let's say you have basically no memory, but only CPU, right? You can provision a high amount of CPU and a low amount of memory with custom VM types and save money there. And then with preemptible nodes, we have to make sure our application is stateless. So if one of the pods goes down, right, like we're not seeing a repetitive action happening, and that would lead to a lot of difficulties in the back end. So want to make sure that all of that is caught. But if your application is ready to face sudden outages like that, and a new pod can come up and continue the operation, then preemptible nodes would be very, very useful because you could save on a lot of money. And then also with HPA and VPA cluster autoscaling, so node autoscaling, it would be great to have everything provisioned and know what would happen with your environment all the time, right? But you won't, like, at certain times, there might be a very high peak, especially if it's customer facing. Maybe if it's internal, you might know what's happening, but you can never know for sure, right? So if there's going to be a high peak or a low peak, and you can leverage GCP's GKE's features like node autoscaling. So at lower times, it'll scale down the nodes, but at higher times, it'll provision more nodes. So just in case you get a sudden increase in traffic, you'll be able to handle that. And then leverage horizontal pod autoscaling, which can base the scaling of your pods off a ton of different things like memory or CPU or even pub sub count, pub sub requests that you're receiving. So make sure to leverage all of the features that GCP offers. And then before you set all of this up, make sure you really understand what environment you're provisioning your cluster in. Like, let's say for a production environment, right? Like, the most important thing is to make sure it's always up and running and everything is getting served. So over provision, right? Whether it's on size or number of VMs, make sure you're always up and running, and make sure it's stable. Whereas with development environment, this is really where you want to save on money, right? Like, run as many preemptible nodes as you can. If something goes down, it's not the end of the world. I mean, depending on the workload, but make sure you know where you're trying to save on money, and make sure you know where you're trying to look at performance.
That's some really wonderful information, Nishal. Mitch, from a customer perspective, what kind of customers are looking at benchmarking? Are they primarily cloud native, or has been your experience?
Yeah, the customers that we work with primarily have been cloud native, Aditya, but even customers who are looking to move to cloud could potentially take advantage of this as they start to look at their on-premise costs versus what they might seek or look at in terms of cloud costs. But a lot of our experience has been with the cloud natives, and our customers have seen just dramatic increases in performance and reductions in cost, 20, 30, 40% in some cases. So it's been a great way for us to help our customers with optimization. We provide other types of services that do that, but this is takes it to a whole new level.
What I'm hearing from both of you, Mitch and Nishal, is the performance gain is multifold, and the cost optimization is also substantial, which makes an important case for customers to consider optimization and leverage the best of the clouds. Right. Nishal, that was around the performance side for Kubernetes. Some of the other initiatives that we did last year around applications and databases. Do you want to talk a little bit about that?
Sure, yeah. So we also benchmarked different applications last year. So Java-based applications on different processors. So it, a lot of customers use Java and a certain version of Java, right? So we wanted to test that out. And there's a really useful tool, SpecJDB, for measuring the important metrics that you need, like critical JOPS and max JOPS. And then also in terms of the infrastructure, right? We were able to see which processor gives the best performance in terms of the application, but also how it handles the application, right? So CPU and memory. And that was for applications. We also tested databases as well. So this includes SQL and NoSQL performance. So we can track specific metrics with tools like HammerDB for different SQL database systems, such as MySQL and PostgreSQL, but also for NoSQL database technologies, right? Like Rally is a really useful tool. We can performance test for Elasticsearch, and of course, Cassandra stress test for Cassandra.
Wonderful. That's a lot of different initiatives that we do around different work streams and areas. We do also have our performance benchmarking offering for customers where we benchmark different kinds of processors, databases, applications, depending on the customer needs. And the interesting part, Nishal's teams are all over the world, depending on the competency. We have teams in South Korea, China, Middle East, India, supporting different kinds of workloads initiatives. Nishal, would you say our engagements for performance optimization are quick and fast? What is the
Yeah.
typical duration for our engagements?
I definitely think we do it pretty quickly. Of course, depending on the size of the team and the workload, it'll change, but usually it's around 4 to 6 weeks, but it can be less, can be more.
It would depend on the workload, that a number of workloads the customers want to test and the end objectives.
Correct, yes.
Right.
And I can add to this, Aditya. Obviously, the process could be outlined and a customer could take this on their own. And some of our customers have done that. But because of our experience and the multiple times we've done this, we've been able to really speed up that process for them, as well as test more so they get the optimal performance. So it's been a great way for our clients to take advantage of our skill set in this area.
What are the key deliverables? What do our customers take away at the end, Nishal?
So we do a very good job of providing as much information to the customer as possible, right? The next time they want to do a project, they could do this on their own if they wanted to. Of course, they could leverage us and we could do it as well quicker and take that away from the customer. But we want to be able to knowledge transfer as much as possible. So we give them a very comprehensive report of all the metrics and information that we gathered, really highlighting the key metrics that they should be looking at. Usually this is in a spreadsheet format, as well as a very detailed analysis documentation, which consists of everything we do, how we ran all of the tests, all the information that was gathered. And this is really where the customer could utilize doing this on their own, as well as a readout at the end, just to make sure we are also helping the customer identify what we believe was captured during the test, what processor worked best, what would be best for their environment currently. That's everything that we provide to the customer.
I think the value that we bring in is that we act as a independent third-party validator and tester who has no biases. The objective is to make sure that the customer is able to leverage the best performance and cost from the different clouds. I know we spoke about GCP, but customer workloads nowadays are on all clouds. So we have the ability to focus on any flavor of Kubernetes, any cloud, and we have flexible teams across to do these quick projects. We also have some quick start offerings for customers. It's worth a mention around helping customers for benchmarking projects, where Bespin teams can come and quickly bring towards outcome-based engagements that can happen in a few weeks, piloting that and then scaling that as required. That was some really good information, Nishal. Mitch, thank you for the continuous support in the field. We will be bringing in more webinars around performance testing, benchmarking, and other initiatives that Bespin does on an ongoing basis. Please hit us up at sales@bespinglobal.com for any questions and queries that you may have. Thank you, everybody. Thank you, Mitch. Thank you, Nishal.
Thank you, guys.